Few get everything right. If you guess here, you miss the point. First question. What is the defining characteristic of stochastic gradient descent? A. Weights are updated using a single or small batch of samples. B. Weights are updated using the full dataset. C. Weights never change during training. D. Gradients are estimated randomly without data. Correct answer is A. Weights are updated using a single or small batch of samples. Second question. Why does stochastic gradient descent introduce noise into training? A. It uses random subsets of data for updates. B. It uses random initialization every step. C. It ignores the loss function. D. It skips backpropagation. Correct answer is A. It uses random subsets of data for updates. Third question. What is a common advantage of SGD over full batch gradient descent? A. Faster updates on large datasets. B. Guaranteed convergence to global minimum. C. No hyperparameters needed. D. Deterministic optimization. Correct answer is A. Faster updates on large datasets. Fourth question. How does SGD help escape shallow local minima? A. Noise allows exploration of the loss surface. B. It enforces convexity. C. It removes saddle points. D. It smooths gradients completely. Correct answer is A. Noise allows exploration of the loss surface. Fifth question. What happens if batch size is reduced in SGD? A. Gradient variance increases. B. Model becomes linear. C. Training stops converging. D. Loss becomes convex. Correct answer is A. Gradient variance increases. Sixth question. Why is shuffling data important for SGD? A. To avoid biased gradient estimates. B. To increase dataset size. C. To reduce model depth. D. To eliminate noise completely. Correct answer is A. To avoid biased gradient estimates. Seventh question. When does SGD typically outperform batch methods? A. When data is large and redundant. B. When loss is convex. C. When training very small models. D. When gradients are exact. Correct answer is A. When data is large and redundant. Eighth question. What is a downside of pure SGD? A. Training can be unstable. B. It cannot scale to large data. C. It cannot use GPUs. D. It cannot optimize neural networks. Correct answer is A. Training can be unstable. Ninth question. How does momentum modify SGD behavior? A. It accumulates past gradients to smooth updates. B. It increases learning rate automatically. C. It removes noise entirely. D. It resets gradients each step. Correct answer is A. It accumulates past gradients to smooth updates. 10th question. Why is SGD widely used in deep learning? A. It scales well to massive datasets. B. It guarantees optimal solutions. C. It removes the need for tuning. D. It works only for CNNs. Correct answer is A. It scales well to massive datasets. 11th question. What is the main goal of learning rate scheduling? A. To adjust step size during training. B. To change network architecture. C. To modify loss functions. D. To shuffle datasets dynamically. Correct answer is A. To adjust step size during training. 12th question. Why is a high initial learning rate often used? A. To enable faster early progress. B. To prevent overfitting. C. To remove vanishing gradients. D. To stabilize late training. Correct answer is A. To enable faster early progress. 13th question. What is a common risk of keeping the learning rate too high for too long? A. Failure to converge. B. Perfect generalization. C. Overregularization. D. Vanishing loss. Correct answer is A. Failure to converge. 14th question. What does learning rate decay achieve? A. Smaller updates as training progresses. B. Larger batch sizes. C. More parameters. D. Better initialization. Correct answer is A. Smaller updates as training progresses. 15th question. Why can reducing the learning rate improve final performance? A. It allows fine-grained convergence. B. It removes noise completely. C. It increases gradient magnitude. D. It avoids backpropagation. Correct answer is A. It allows fine-grained convergence. 16th question. What is step-based learning rate scheduling? A. Reducing learning rate at fixed intervals. B. Randomly changing learning rate per batch. C. Increasing learning rate over time. D. Removing learning rate entirely. Correct answer is A. Reducing learning rate at fixed intervals. 17th question. What is cosine annealing designed to do? A. Smoothly vary learning rate over training. B. Randomize gradients. C. Enforce constant updates. D. Freeze model weights. Correct answer is A. Smoothly vary learning rate over training. 18th question. Why are warm-up phases sometimes used? A. To stabilize early training dynamics. B. To speed up inference. C. To reduce dataset size. D. To remove regularization. Correct answer is A. To stabilize early training dynamics. 19th question. What happens if learning rate becomes too small too early? A. Training may stagnate. B. Model diverges instantly. C. Gradients explode. D. Overfitting disappears. Correct answer is A. Training may stagnate. 20th question. How does adaptive scheduling react to validation metrics? A. It adjusts learning rate based on performance. B. It fixes learning rate permanently. C. It ignores loss values. D. It modifies batch size. Correct answer is A. It adjusts learning rate based on performance. 21st question. What is the core purpose of backpropagation? A. To compute gradients of the loss with respect to parameters. B. To initialize weights randomly. C. To normalize inputs. D. To evaluate model accuracy. Correct answer is A. To compute gradients of the loss with respect to parameters. 22nd question. How does backpropagation propagate error signals? A. From output layer backward through the network. B. Randomly across layers. C. Only within hidden layers. D. Only through activation functions. Correct answer is A. From output layer backward through the network. 23rd question. Why is the chain rule essential for backpropagation? A. It allows gradient computation through composed functions. B. It removes nonlinearity. C. It stabilizes learning rate. D. It guarantees convex loss. Correct answer is A. It allows gradient computation through composed functions. 24th question. What information is required to perform backpropagation? A. Model outputs and true targets. B. Input features only. C. Activation functions only. D. Batch size. Correct answer is A. Model outputs and true targets. 25th question. What happens if gradients vanish during backpropagation? A. Early layers learn very slowly. B. Model accuracy increases. C. Training becomes faster. D. Loss becomes convex. Correct answer is A. Early layers learn very slowly. 26th question. How do ReLU activations help backpropagation? A. They reduce vanishing gradient effects. B. They guarantee smooth gradients. C. They remove noise entirely. D. They eliminate the need for loss functions. Correct answer is A. They reduce vanishing gradient effects. 27th question. What role do weight gradients play in training? A. They guide parameter updates. B. They measure model accuracy. C. They define input distribution. D. They control batch size. Correct answer is A. They guide parameter updates. 28th question. Why is backpropagation computationally efficient? A. It reuses intermediate computations. B. It computes gradients numerically. C. It ignores hidden layers. D. It avoids matrix operations. Correct answer is A. It reuses intermediate computations. 29th question. What breaks backpropagation in a network? A. Non-differentiable operations. B. Random initialization. C. Large batch sizes. D. Deep architectures. Correct answer is A. Non-differentiable operations. 30th question. Why is backpropagation considered supervised learning dependent? A. It relies on labeled targets. B. It requires large models. C. It cannot generalize. D. It enforces linearity. Correct answer is A. It relies on labeled targets. 31st question. What is the defining feature of recurrent neural networks? A. They maintain hidden state across time steps. B. They use convolution filters. C. They require fixed size inputs. D. They cannot process sequences. Correct answer is A. They maintain hidden state across time steps. 32nd question. Why are RNNs suitable for sequential data? A. They model temporal dependencies. B. They reduce dimensionality. C. They enforce sparsity. D. They eliminate noise. Correct answer is A. They model temporal dependencies. 33rd question. What is a major training difficulty with vanilla RNNs? A. Vanishing and exploding gradients. B. High memory usage. C. Slow inference speed. D. Lack of labels. Correct answer is A. Vanishing and exploding gradients. 34th question. How does backpropagation through time differ from standard backpropagation? A. It unfolds the network across time steps. B. It ignores hidden states. C. It removes activation functions. D. It uses different loss functions. Correct answer is A. It unfolds the network across time steps. 35th question. Why are RNNs sensitive to long sequences? A. Gradients accumulate over many time steps. B. They cannot use GPUs. C. They require fixed learning rates. D. They enforce linear models. Correct answer is A. Gradients accumulate over many time steps. 36th question. What problem do LSTM cells address? A. Long-term dependency learning. B. High-dimensional inputs. C. Overfitting from deep layers. D. Small batch sizes. Correct answer is A. Long-term dependency learning. 37th question. How do gated mechanisms improve RNN performance? A. They control information flow through time. B. They reduce sequence length. C. They remove hidden states. D. They eliminate noise. Correct answer is A. They control information flow through time. 38th question. Why are GRUs considered computationally efficient? A. They use fewer gates than LSTMs. B. They eliminate recurrence. C. They avoid backpropagation. D. They require no memory. Correct answer is A. They use fewer gates than LSTMs. 39th question. What is a common real-world application of RNNs? A. Time series forecasting. B. Image segmentation. C. Object detection. D. Tabular regression. Correct answer is A. Time series forecasting. Last question. Would you pass a real technical interview? 40th question. When are RNNs less preferred compared to transformers? A. When modeling very long-range dependencies. B. When sequences are short. C. When data is labeled. D. When models are shallow. Correct answer is A. When modeling very long-range dependencies. Comment your result below.